Welcome back once again. We just peep into another module, Models of Teaching Physical Science. There are different techniques which are applied in classrooms specially designed to produce an output in a particular area. Models of teaching are such an instructional strategy for realizing certain objectives depending on the nature of the task oriented in the model. Models of teaching differ from general methods of teaching in that they intended for certain specific purpose and cannot be applied in general, whereas general approaches to teaching are considered to be applicable for all teaching situations. The research literature on effective instruction highlights that teachers can use students more effectively using the direct or explicit instruction model when the desired outcome is a score on a standardized test of basic skills. Bruce Joyce and Marsha Weil in 1980 described a model of teaching as a plan or pattern that can be used to shape curricula, to design instructional materials and to guide instruction in the classroom and other settings. Different families of models. Bruce Joyce and Marsha Weil identified 23 models and have classified into 4 different families. These 4 families are: first one, information processing models; second, personal model; third, social interaction model; and the last one, behavior modification model. Information processing model. These models focus on the methods associated with information processing, and its approaches are more linked to concepts and principles developed in cognitive psychology. They consider mental processing skills, inquiring, developing powers of observation and reasoning as important. The various models which belong to this category are: concept attainment model, inductive thinking model, inquiry training model, advanced organizer model, memory training model, cognitive growth model, biological science inquiry model. Next family, the personal model. These models focus on self-concept, self-esteem, positive self-direction and development of selfhood, independence, creativity and curiosity, and the development of affect and emotions, increasing personal awareness, and mainly concentrate on increasing individual potential. The various models which belong to this category are: non-directive teaching model, synectic model, awareness training model, classroom meeting model. Next family is social interaction model. These models focus on developing the concepts and skills needed to work in groups. Cooperative learning has demonstrated the ability to impact standard achievement measures as well as group interaction. They emphasize the relationship of the individual with the society and aware about personal and social values. The various models which belong to this category are: group investigation model, role playing model, jurisprudential inquiry model, laboratory training model, social stimulation model, social inquiry model. Next family, the behavior modification model. These models focus on observable skills and behaviors, that is, they emphasize on the changes in the visible behavior of the learner. The various models which belong to this category are: contingency management model, self-control model, training model, stress reduction model, desensitization model, assertiveness training model. Basic elements of families of model. Bruce Joyce and Marsha Weil have defined a definite structure for each and every model. The important aspects of this structure are: focus, syntax, principles of reaction, social system, support system, instructional effect and nurturant effect. Focus. Focus means the aim or objective which is attained through this model. It is the immediately attainable goal of specific model which is concerned. Each and every model has got wide and different focus. Syntax. Syntax means the structure of the model, the systematic sequence of activities or procedures highlighted for the transaction of the model is termed as syntax. Each and every model has got its own well-built syntax or structure. Principles of reaction. Principles of reaction means the teacher responds to the reactions of the students in guiding through the system. The teacher should focus the pupils' attention, evaluate and guide their thinking strategies. Here, teachers' reactions are purposefully planned to lead the pupil to the desired focus. Social system. The role assigned for teacher and pupil constitutes the social system. The teacher has the role of selecting the concept, organizing and sequencing the data. Teacher controls the different phases and students are asked to interact throughout the phases. Normally, a moderate social system was followed by giving importance to both teacher and pupil. Support system. All the instructional materials or elements other than the teacher and pupil come under the support system. The reference materials, audiovisual materials, ideas for promoting motivation, etc. come under this heading. Instructional effect. Instructional effects are the direct outcome of the model. All those achievements as part of the instruction through a particular strategy are called their instructional effect. Nurture and effect. Nurture and effects are the indirect effects of the model. The qualities like reasoning, creativity, tolerance of mistakes, objectivity are developed in classrooms as part of the models of teaching. People are conscious about the awareness in alternate perspectives, inductive reasoning, etc. Now, we will discuss some models of science teaching. First one, concept attainment model, which was given by Jerome S. Bruner. Concept attainment model belongs to the family of information processing models. The major proponent of this model was Jerome S. Bruner. The model mainly focuses on attainment of concepts. Learning concepts can accelerate the learning process because concepts become the fundamental meaningful aspect of knowledge. What is a concept? A concept is a mental representation or mental picture of some objects or experience. The concepts deal with category of objects which share common properties. Concept can be viewed as a generalized idea suggested to the individual by object, symbol or situation. Concepts, we go with a theoretical discussion. According to Bruner, a concept includes three elements. They are name, attributes, exemplars. Name. Name refers to a term or a label given to a category, or it is a word describes for communication. Example, dispersion, inference, force, momentum, energy, etc. Attributes. The features or characteristics of objects are called attributes. Attributes refers to the special characteristics needed to define a concept. They are features or characteristics on the basis of which a number of items could be categorized into a particular group or class that represents the concept. There are two different types of attributes. They are essential attributes and non-essential attributes. Essential attributes. These are common features or characteristics of the concept. These are so important that without which you cannot define a concept. For example, the essential attribute for the concept physical change are: these are temporary changes, no new substances are formed, these are reversible, etc. Non-essential attributes. These are the features or characteristics which give value to a concept. The non-essential attributes may not be needed to define the concept, but without this, the nature of the concept in detail cannot be studied. For example, color, size, shape belongs to this classification. Exemplars are the actual representation of the essential attributes in specific form. All the essential attributes will be present in all the examples where we can see the presence or absence of non-essential attributes. Concept formation. Concept formation takes place as comparison of the different positive examples and differentiation between the negative examples. Comparing positive examples and discriminating from the negative examples leads to the attainment of concepts through various attributes. Concept learning can be done by double discrimination, that is, identifying the common attributes of the positive examples and identifying the non-common attributes of the positive examples. Concept attainment can be checked if the students have the ability to categorize exemplars and non-exemplars. Ability to describe exemplars in terms of essential attributes. Bruner has defined 4 different strategies for concept attainment. They are simultaneous scanning, successive scanning, conservative focusing, focus gambling. Concept attainment model. Syntax. The syntax or scientific structure of concept attainment model involves three phases. Phase 1, presentation of the data and identification of the concept. In this phase, teacher presents labeled examples as positive and negative. Students are asked to compare the labeled examples based on their nature and hypothesize the similarities. They can define the concepts based on the attributes that they have identified. They define in their own words about the concept. Phase 2, testing the attainment of the concept. In this phase, teacher presents unlabeled examples. Students identify these examples based on the definitions of the concept they have made and classify as positive and negative examples. Teacher confirms the student's hypothesis and students generate further examples. Phase 3, analysis of thinking strategies. In this phase, students describe their way of thinking or they arrive this concept. They discuss how they have framed the hypothesis and how this is linked to attributes. Teacher evaluates the strategy adopted by the students. There are two types of thinking strategies adopted by the learner. Social system. The concept attainment model follows a moderate structure. The teacher has the role of selecting, sequencing and presenting the examples. Teacher controls the class by directing students to concentrate on setting hypothesis and reasoning based on hypothesis. Students are careful in categorizing and reasoning based on hypothesis. Principles of reaction. The model ensures active participation from the teacher and pupil throughout the discourse of the model. Teacher's reaction to students' responses is purposeful and this can only lead to hypothesis. Teacher focuses the attention of people in relevant matters so that the class does not deviate from the concept. Teacher encourages pupils' participation throughout the class. The teacher can act as guide and facilitator. Support system. The support system for this model is well organized examples arranged as positive and negative, and the audiovisual materials used the free atmosphere that promotes active participation in the classroom. Instructional effect. The major instructional effects are improved concept building strategies, getting clear notion about the nature of concepts, development of specific concepts, attainment of new concept, discrimination between the similar concepts, etc. Nurturant effect. The nurturant effects are inductive reasoning, awareness of alternative perspective, tolerance of ambiguity, development of logical reasoning, effective communication, etc. Inquiry training model by Richard Suchmann. Inquiry training model is on the basis that the mode or process of inquiring can be taught in the classroom. This model was developed by Richard Suchmann to teach the students the art of independent inquiry in a disciplined way. The general role of inquiry training is to develop the intellectual disciplines and skills necessary to raise questions and search out answers stemming from their curiosity. The model is based on the assumption that all knowledge is tentative and there will be multiple answers for a particular cause-effect situation. People start inquiring when they get puzzled, and team effort can lead to the better solution of a problem. Syntax. The syntax or scientific structure of inquiry training model involves 5 phases. Phase 1, encounter with the problem. Here, first thing is that explain the inquiry procedures, present the discrepant event. Phase 2, data gathering. Verification. Here, verify the nature of objects and conditions and verify the occurrence of the problem situation. Phase 3, data gathering, experimentation. Search for the data, isolate relevant principles to find out the relation and hypothesize the causal relationship. Phase 4, formulation of explanation. Formulate rules or explanations as solution to the discrepant event. Here the methods are simple linear causation, theory of properties, application, analogy, etc. Phase 5, analysis of inquiry process. Analyze the inquiry strategy to develop more effective ones. Illustration of the model. In the phase 1, the teacher presents the problem situation and explains the inquiry procedures. The problem situation is presented in the form of a story, experiment, activities, puzzles, etc., and create a discrepant event. The teacher then explains the rules for this model. Students are requested to find out the concept underlying the story by asking questions to the teacher. The questions to be asked are in the form that the teacher answers only yes or no. If the questions are not of this form, students should rephrase the question in the yes or no form. The phase 2 starts with simple questions from the part of the students about the situation. As they have gathered sufficient amount of information about the problem situation, then it leads to phase 3. Here, all the data that have obtained are fruitfully linked and purely theoretical questions are asked at this stage. The wording of the questions at this stage will be if, suppose, then, etc. After gathering theoretical information, students with the help of the teacher formulate explanations using simple linear causation, theory of properties, application, analogy, and finally finds the solution to this problem. At the last stage, phase 5, they again remember the way or means by which they found the solution to this problem. Principles of reaction. Ensure that phrasing of the questions is done correctly. Ask students to rephrase invalid or vague questions. Point out the invalid statements. Always keep the language of the inquiry process. Neither approve nor reject students' theories. Encourage interaction among students. Social system. The social system of this model is highly structured with the teacher controlling the interaction. Teacher has the dominant role in presenting the puzzling situation. Even then, the inquiry process leads through cooperation. The teacher should categorize the questions as relevant, guide the situation to the correct path, record the observation or statements, should help the students to arrive at an explanation. The model emphasizes group activity. Support system. The main support system of this model is set of discrepant events, teacher's knowledge of the inquiry procedures, and resource materials related to the problem. Instructional effect. The instructional effect of this model are scientific process skills like observing, collecting and organizing data, identifying and controlling variables, formulating and testing hypotheses, explanations and inferring are developed. Strategies for creative inquiry is developed and inquiry nature is inculcated. Nurturant effect. The nurturant effect of this model are autonomy in learning, logical thinking, tentative nature of knowledge, tolerance of ambiguity, etc. Next, inductive thinking model by Hilda Taba. Inductive thinking model is designed to train learners in mental processes by which we interact with the data or bodies of information, interpret these and arrive at some generalization. The model is based on series of mental strategies developed by Hilda Taba to improve mental processes, especially the ability to categorize and use categories. The model is based on 3 important assumptions. First one, thinking can be taught. Second, thinking is an active interaction between individual and data. Third, process of thought evolved by a sequence that is lawful. Syntax. The syntax or scientific structure of inductive thinking model involves 3 strategies and each strategy has got 3 phases. Strategy 1, concept formation. In that, phase 1, enumerating and listing. Phase 2, grouping. Phase 3, labeling and categorizing. Strategy 2, interpretation of data. Phase 4, identifying critical relationship. Phase 5, exploring relationship. Phase 6, making inferences. Strategy 3, application of principles. Phase 7, predicting consequences, explain unfamiliar phenomenon. Phase 8, hypothesizing, explaining or supporting the predictions and hypothesis. Phase 9, verifying the prediction. Procedure. The first strategy of the model involves listing, grouping and labeling of the data which are either recalled from earlier experiences or where the learners are exposed to some kind of sensory experience. After having listed the items, learners are asked to group the items based on their similarities. Then group can be named with their scientific name with the help of teachers. In the second strategy, the groups are explored based on their critical relationship. Here, learners analyze each and every item of the group and find out scientific relationship, and after that they explain how they found out cause-effect relationship. Now, after explaining about the nature of the group, they make generalized inference about the whole data. In the last strategy, learners are asked to apply their generalizations to unfamiliar situations. They form predictive generalizations, and at last the conditions of these generalizations are reasoned logically. Principles of reaction. Teacher should closely monitor how students are processing information. Next, teacher initiated questions in each phase of the model. Teacher should guide and direct as and when needed. Next, teacher should be motivating and encouraging. Last, teacher should maintain the pace of the class. Social system. The model has a high to moderate structure. The teacher is initiator and controller of activities. The entire system is followed through complete cooperation. Active participation of the students is involved in listing and grouping of the examples and exploring relationship. Support system. There should be sufficient number of raw data to process the information. Field trips can be arranged as part of data collection. Use of audiovisual media for the presentation of the data. Instructional effect. The instructional effect of this model are direct influence on concept formation. Concepts can be taught well through this model, and specific concepts learning is developed. Nurture effect. The nurture effect of this model are students can develop proper attention, logic, sensitivity to language, and awareness to the nature of knowledge. Hope you have got a very clear idea about models of teaching and different families of models. Let us summarize the things that we have discussed in this module. The module discusses about the different strategies of teaching science specially meant for realizing the specific instructional objectives. The module mainly discusses about a pattern like models of teaching specially meant for realizing some specific purposes. The module focuses on general introduction to models of teaching, families of model, and detailed description about concept attainment model, inquiry training model, and inductive thinking model. Before we conclude, please try to answer the following questions. What do you mean by concept attainment model? Differentiate the different strategies for the attainment of concept. Distinguish between inquiry and enquiry in science. Books for reference: Bruner, J.S. 1996, Towards a Theory of Instruction, Harvard University Press, Cambridge. Hilda, Taba, 1967, Teacher's Handbook for Elementary Social Studies Reading, Mass Addison Wesley Publishing Company. Ratha Mohan, 2002, Innovative Science Teaching for Physical Science Teachers, Prentice Hall of India Private Limited, New Delhi. Thank you for watching this program. We will meet again with another topic. Till then, goodbye. Take care.